One of the valuable aspects of the DIPPR database is that it is an evaluated database. This webinar explains why being an evaluated database is important. Evaluation means that all of the data that go into the database are assessed for accuracy and consistency. Many different factors, such as experimental techniques, the purity of the compounds tested, and ambiguity in reporting, contribute to the accuracy of thermophysical property data. Therefore, before any data are added into the DIPPR database, extensive quality checks are done to ensure that the values recommended for each property are the most accurate possible. The DIPPR database uses dozens of quality checks. Some are fairly simple. For example, the melting point of a compound should be less than the normal boiling point, and the normal boiling point should be less than the critical temperature. More complex quality checks rely on rigorous thermodynamic relationships. An example of this is the Clapeyron equation. The Clapeyron equation relates the vapor pressure, the heat of vaporization, and the molar volumes of the vapor and liquid phases. This equation can also be written in terms of molar densities of the vapor and liquid phases. Take orthoterphenyl for an example. This compound is composed of 3 benzene rings, 2 of which are attached to the other in the ortho position. For this compound, a large amount of experimental data exists for the liquid density over a fairly wide temperature range from around 300 Kelvin to about 720 Kelvin. Good experimental data are also available for the vapor pressure. Notice that here we're plotting the natural log of the vapor pressure versus the inverse temperature, so that the data range from around 340 Kelvin to around 615 Kelvin. Now let's look at the heat of vaporization. Notice that 2 sets of data follow different trends. The orange triangles flatten out at low temperatures compared to the data represented by the blue circles. Both sets are from experimental data, and the literature does not suggest which is more reliable. However, the Clapeyron equation can be used to help us determine which data set to trust. Specifically, we take the slope of the vapor pressure curve, the values for the liquid density, and calculate the liquid or the vapor densities from an equation of state such as SRK. The results of this are shown in the yellow line. From this we see that we should accept the blue data and reject the orange data, as the orange are not thermodynamically consistent with the other experimental data we have.